Ready?
Kalau dia dia cakap
Okay.
dah. Okay, good morning. Assalamualaikum and good morning. My name is Muhammad Shafiq
My name is Nurin Afifah.
and we are going to present about our Lab 1. Okay, today for Lab 1, it is a project titled Hybrid Renewable Energy Management System, which uses a combination of solar and wind power controlled by a Siemens PLC. So the purpose of this lab is to design and implement a source selection controller that can automatically choose the stronger renewable source based on real-time sensor data, and the system also uses two analog sensor, which is solar irradiance sensor and wind speed sensor, both providing a 0 to 10 volt signal to the PLC. So now we are going to show you the system. So firstly, we start with system on operation or for FC16. Okay, so firstly, we can test the system by clicking the specs. And now, by selecting true on system on, the system will be activated. By clicking selecting true for stop button, the stop button will be activated. So the purpose of system on is this block basically acts as the master power control for all our system, because every system will start with system on. And next is for solar. Firstly, we need to stop, and then I will start with solar operation. So for solar operation, here is the value. So by inputting the value here, okay, wait, 0. Okay, here's the value for solar. So for example, I put 10,900 here. Okay, the value will show here and also the percentage of the solar power. And next is firstly we turn back off the system. And now for wind operation for FC18. Okay, wind operation is already on. So firstly, we check for wind speed sensor. So maybe we put 14,000. Okay, here we can see stated the value I've entered, and the value of percentage also shown here, which is 49%. Okay, the reason for solar and wind operation are having their own block, because the block ensures the solar signal is properly conditioned and being used by the controller. And for wind operation, this also ensures the wind signal is clean and scale and ready for the decision making for the system. And next is we will be testing the hysteresis operation. So click the specs. Okay, firstly, hysteresis. Okay, firstly we will check for the first line for 3%, which is this one. So we can see the system will lead up green to make sure the hysteresis for 3% works correctly. Now for network 2, wait, network 2. We'll check for network 2 now. If we turn on hysteresis for the 4%, this one will lit up. And we can see only that one will lit up and the others would. The next is for hysteresis 5. So, okay. Hysteresis 5%, it will lit up green. So, that's all for me. Now, Nurin will continue the next part. Thank you.
Okay, thank you, Shafiq. So now let's move on to the comparator operation. In this operation, we are comparing the values from two sensors, the solar voltage percentage and also the wind speed percentage. These values are stored in memory words, which is the MW60 for solar and MW21 for wind speed percentage. So if we open here, we can compare the values of these two percentage, in which in the network 1, the PLC checks if the solar voltage percentage is greater than the wind. As you can see here, the symbol indicates that the solar is greater than the wind. So if the value is high, by changing it to more than 14,000, let me put around 20,000 right here. The network will become true. The network 1 will become true, and then if the values if the values are the same for the wind in the network 2, the PLC does the opposite check. It compares if the solar value is lower than the wind value. So when the solar value is lower, this relay will turn on. But if both of the sensor are below than the if it's below than 5%, this means that the both renewable sources are too weak to supply power. But we don't switch immediately. After 10 seconds, timer is used to make sure the reading stays below 5% continuously. If both values stay below the 5% for the whole 10 seconds, the timer finish and the PLC will turn on. The PLC will turn on for when only both sensors are low for more than 10 seconds. So as you can see right here, the relay 3 are on after both of these percentage are below than 5%. So now let's move on to the fail safe condition block. In this block, the network 1, the PLC calculates the average value of the solar and wind percentage. First, it adds the two sensor value together using the add block. The result is stored in memory word MD70. So the next program divides these two by using the IV block. This gives us the average input value, which is stored in MD80. Right here, the average input. Next, for the network 2, the PLC checks if the average input is below than 5%. If the average is less than 5%, the input condition becomes true and it activated the on timer. The timer is set for 10 seconds. If the average stays below the 5 seconds for more than 10 seconds, the timer finishes. When the timer reaches 10 seconds, the output coil Q2.1 is turned on. This coil is stable alarm. I'm sorry. The the output coil is Q1.6, and then the coil label alarm is on. So this network triggers an alarm when both energy sources are consistently weak. So if you can see right here, if the values are more than 5%, right here it will show that the alarm is not on. But if both of the sensor are below than 5%, the timer will start counting for 10 seconds, and after 10 seconds it will turn on like this. So next, let's move on to the battery charging. In battery charging, in the network one, the PLC checks if the system is turned on, and if the relay one is active, the relay one represents the solar source. When both conditions are true, the move block transfers the solar irradiance sensor value into the buck boost input. This means that the solar is selected as the main source. The buck boost converter receives the solar sensor value for charging. Let's open it. And then for the network 2, the PLC checks if the system is on and if relay 2 is active. Relay 2 represents the wind energy source. When both conditions are true, the move block transfer the wind speed sensor value into the buck boost input. This means the buck boost converter uses the wind energy to change the battery when wind is selected. And lastly, the network 3 is the battery mode. The no solar and no wind. In this network, the PLC checks if the system is on and relay 3 is active. Relay 3 represents the battery checkup mode. When this condition is true, the move block transfer a constant value of 0 into the buck boost input. This tells the system that no renewable source is available, so the buck boost converter stops taking input and relies on battery mode instead. So, based on the simulation, if the relay 1 is on, let me put uh, let's say the value is 28 28,000 for the solar, and the wind speed is also 28,000. And also the system is on. Okay. So as we see here, the relay one is on. In the battery charging, the solar will charge also to the battery, and if the values are otherwise, which is around 28,000, and for the solar irradiance is 900, let's say. In the buckles for the relay 2, it will automatically will be on for the buckles. And if the value for both of the sensors are below than 5%, the system here will show that the system on relay 3 will be on and the buckles will be on also. So that is all for the um for our lab of hybrid renewable energy. Apa? For our hybrid renewable energy management. So thank you for listening and that's all.